All right, we're ready to answer questions A, B, and C in this video. We just graphed this first equation about mailing a letter that weighs up to that weighs 13 ounces or more. We've already graphed it and we've already drawn our graph and written our domain and range in the table. So if you read question A, it says evaluate C of 17. What does this mean in the context of the problem? This can be very confusing, but if you remember that our original function is C of W, this is basically saying what is C, and if I were you, I would probably write this on my paper, when W equals 17. All right, to add a layer onto that, we said that W is going to be represented with the variable X in our calculator because our calculator only does X and Y. So I could think anytime I see the C, that's going to be my Y. Anytime I see the W, that's going to be my X. I might write this out to the side. All right, so this is asking us to find Y when X is 17. And we did a problem like this earlier in our calculator. So what we want to do is go, we're in our graph, we want to go to that calculate menu. So I'm going to hit the second button and then the word trace. And that brings up my calculate menu. Because I know my X value, I want to go to value. And down here, I see the cursor blinking under X equals. So I want to type in 17 because we said we're going to find it when our W is 17. We said in this problem, W is our X. I know that's confusing. All right, so then we hit enter. Well, the calculator does all the hard work for us. It tells us that Y equals 1.33 when W is 17. Remember that Y is the cost in dollars. So we're talking about money. So that's $1.33. So we could say C equals 1.33. And then to answer this question, it says, what does it mean in the context of the problem? Well, that means that it costs $1.33 to send a letter that weighs, we said 17, and our weights were in ounces, so 17 ounces. All right, it costs $1.33 to send a letter that weighs 17 ounces. All right, so now let's go into part B. In part B, it says solve C of W equals 150. And what does this mean in the context of the problem? So they're not asking us, they're not giving us the input like in A. They're not giving us the X value. They're giving us the output or the Y value. So what we know here is that Y is going to be equal to 1.50, and they're basically asking us for X. So these are the two types of function problems we've seen a lot of. Okay, this is going to be something we do differently. So we did an example earlier, but if we know the Y value, we're going to go ahead and graph it. So go back to the Y equals menu, and under Y2, we're going to type 1.50. You could also just type 1.5. So Y equals 1.50. And again, we got that because that's our output. That's our cost. All right. So now I'm going to hit graph. And what I want to see, that new graph intersects my old graph. And what I want, and I'm sorry, the screen's, sorry, give me just a second. The screen's driving me crazy. Okay. All right, what I want to graph is I want to find out where that intersection is. I know my Y value at that intersection because that's where Y is equal to 1.5, but I want to know my X value at that intersection. So now that I've graphed that, I'm going to go to second trace. And I don't want to go to value, but I want to go to intersect. So I can use the arrow to scroll down, and then I hit enter. So remember, it's going to ask me 3 questions. It's going to ask me to guess. So it says first curve, question mark. I'm going to scroll over to where that intersection is. Second curve, my cursor's already there. I'm just going to hit enter. And then guess, I'm just going to hit enter. And it gives us this answer. X equals 17.8095. And if you remember in the directions, it told us to round to the 3rd decimal place. So 17.8095, that 5 is going to tell us to round up. So really 17.810 is what we get for that. So our original value was X equals 17.8095. If I'm rounding to this decimal place, the 5 tells me to round up. So I get X equals 17.810 essentially, or 8.10. What does this mean in the context of the problem? Well, it gave us our output, which was cost. So that means that this is our input weight. So we could say a letter that weighs 17.810 ounces costs $1.50 to mail or to send. All right, so a letter that weighs 17.810 ounces costs $1.50 to mail or to send. The last question is, why won't this equation work for a letter that weighs 10 ounces? And if you go back, we don't really need the calculator to think about this. If you reread this, it says that it costs 49 cents to send a letter that weighs up to 13 ounces. So that really means that even if the letter weighs like 5 ounces, it's going to cost 49 cents. So from weighing essentially almost nothing to 13 ounces, that's just how much it costs. So then each additional ounce costs this. So this equation is really for 13 ounces or greater. So why won't the equation work? Well, because it costs 49 cents to send anything between 0 and 13 ounces. Okay, you are going to try the next 2 problems. I don't have videos for those, but you can always go back and rewatch these videos to help you.